Hello friends. Now in this lecture we are going to discuss units and its measurements. We know that we are measuring some physical quantities. What is actually physical quantity? A quantity that can be measured is called as a physical quantity. In previous classes we have already discussed measurable quantities as well as non-measurable quantities. My question is, what is measurable quantities? If I go for measurable quantities, length, mass, velocity, temperature, area, volume, density, etc. are the measurable quantities. If I go for non-measurable quantities, I will go for buildings, buses, rooms, road. One of the big city are called as a non-measurable quantities. If I classify physical quantities, I can classify into two categories. First one is a fundamental quantity, second one is a derived quantity. So my question is, what is fundamental quantity? If I go for fundamental quantity, a physical quantity which does not depend on any other physical quantity for its measurement. A physical quantity which does not depend on any other physical quantity for its measurement is called as a fundamental quantity. Similarly, if I go for derived quantities, the physical quantities which are expressed in terms of more than one fundamental quantities, that is called as a derived quantity. Means derived quantities are depend on more than one fundamental quantities for its measurement. That's about the physical quantities. Now again come to the classification fundamental quantity and derived quantity. If I go through the fundamental quantities, there are 7 fundamental quantities. First one is the length, whose SI unit is a meter, measured or symbol is a m. Second fundamental quantity is a mass, measured in a kilogram, symbol is a kg. Third fundamental quantity is a time, time unit seconds, symbol small s. Fourth fundamental quantity temperature, SI unit Kelvin, symbol small k. The next fundamental quantity electric current is ampere, symbol capital A. Luminous intensity, SI unit candela, symbol CD small. Next fundamental quantity amount of a substances, unit is a mole, MOLE, and symbol MOL in a small letters. So that's about the fundamental quantities. Now there are two supplementary quantities. One is a plane angle measured in a radian and solid angle measured in a steradian. Okay, now let's move towards a derived quantities. If I consider velocity, that is unit meter per second. Velocity is nothing but a displacement per unit time, that is displacement upon time. Second, acceleration, that is meter per second squares. Formula is a acceleration is equal to velocity upon time. Next one, work. Work is measured in a joule as well as kilogram meter square per second square. And formula is force into displacement. Pressure, kilogram per meter per second square, and formula is pressure is equal to force upon area. So if I look at the derived quantities, they are having some formulas, and in formulas there are two things, like for velocity there is a displacement and time. It means that velocity is depend on displacement and time, that is displacement having its own fundamental unit, that is meter, and time having its different unit, second. So derived quantity velocity is depend on meter and second, that is it is made up from two fundamental units. Okay, so derived quantities are depend on two or more fundamental quantities for their measurement. What is the system of unit? A set of collection of a fundamental and derived unit is called as a system of unit. Unit of a physical quantity is standard used for the measurement of that physical quantities. If I go for CGS, that is centimeter gram second system, MKS meter kilogram second system, FPS foot pound second system, SI system international. If I look at the above four, all these system unit used in India from long years. In 1971, the 14th International General Conference on Weight and Measures recommended the use of an international system of units. So, from this we are using different systems, but preferentially in India we are using SI systems nowadays. Already we have discussed there are two supplementary quantities. I will go one by one for them. If I discuss about the plane angle normally we are using units radian represented by RAD in small letters. This is the ratio of length of an arc of a circle to the radius of the circle. That is d theta is equal to ds upon dr as shown in a figure. Solid angles, d ohm. This is the three-dimensional analog of a plane angle, that is d theta, and it is defined as the area of portion of a surface of a sphere to the square of the radius of a sphere. I will repeat it again. This is the three-dimensional analog, that is the theta of a plane angle, and is defined as a area of a portion of surface of a sphere to the square of the radius of the sphere. So, for solid angle subtended by the area ds at a O point is the d ohm is equal to dA upon r square. So, similarly we can calculate solid angle subtended by the entire sphere. We know that for sphere there is a formula 4 pi r square, and if I divide it by r square will get cancelled. So I can easily write here, which is nothing but a 4 pi r square divided by r square. Here r square get cancelled. So answer will be a 4 pi. That will be my answer for the solid angle subtended by entire sphere at its center.